Alright, today's video covers the homework that was assigned last Friday, page 521, number 30 through 44 even. Here we go. Let's start with number 30. You were asked to graph y equals 4x over x to the third minus 4x. In order to do this, we have to first factor everywhere. If we factor everywhere, again in the denominator here, we can undistribute an x, which gives us x squared minus 4. So then when we factor it, we factor it further, we have x times x plus 2 and x minus 2, because this is the difference of squares. Now, our points of discontinuity. Our points of discontinuity are whatever makes the denominator 0. So we're only looking at the denominator, which is at x equals 0 for the first one. This factor is x equals negative 2. And this factor gives us x equals positive 2. The x's, however, will cancel from the top and the bottom. That means that this x equals 0 is a hole in the graph. At x equals negative 2 and x equals positive 2, these are both vertical asymptotes. Let's also talk about the horizontal asymptote. If we go back to our original function, when everything is multiplied together, you can see our highest exponent is x to the third. So we have a horizontal asymptote at 0 x to the thirds over 1 x to the third, or y equals 0. It's a horizontal asymptote. Now, the only things left to find before we can begin to graph are our x and y intercepts. In this one, our x-intercepts, remember that we are putting 0 in for y. When we put 0 in for y and we multiply this over, right, or this over in this case, I would have 0 equals 4 over x plus 2 times x minus 2. And when I multiply this over to 0, I get 0 equals 4, which means there is no x-intercept. I can get rid of that. My y-intercept means I put 0 in for x. So in this case, I have y equals 4 over 0 plus 2 times 0 minus 2. Or y equals 4 over negative 4 or negative 1. So we have a y-intercept at 0, negative 1. So let's take all of this information and we graph it. So first, we have a vertical asymptote at x equals negative 2. We have a vertical asymptote at x equals positive 2. We have a horizontal asymptote at y equals 0, which is the x-axis. And we have a y-intercept at 0, negative 1. At negative 1, it's right here. But you'll notice that when x is 0, it makes a hole. So this y-intercept is a hole in the graph. Now, we take from here and we approach our asymptote in either direction. There's two more pieces of the graph. Now, we should test it to see where they occur. If I plug 3 into my function, right, I end up with a positive number, which tells me that the graph is in this first section, and it's also going to be in this third section over here. This is number 30. Let's talk about number 32. For number 32, our function is y equals x times x plus 1 over x plus 1. So it is all factored everywhere, so our points of discontinuity are at x equals negative 1. Well, since this factor will cancel, that makes this x equals negative 1 a hole in our graph. The remaining function we have is y equals x. If you go back and look at this, this means that we have no horizontal asymptote either. So, x and y intercepts. x-intercept. Means I put 0 in for y. So if I put 0 in for y, I get 0 equals x. So x also is 0. Finding the y-intercept means I put 0 in for x. So I have y equals 0. So it crosses at the origin. Let's graph what we know. So we know that this is going to cross at 0, 0. The function that's remaining, y equals x, is just a line, which has a slope of 1. So we're going to have this line that goes up in this direction. But then we also have this hole that occurs at x equals -1. So we're going to have a small hole in the graph right here where x equals -1. Oops. All right. Let's look at number 34. Number 34. Our function y equals 3x over x plus 2 squared. Points of discontinuity are what makes the denominator 0, which is at x equals -2. Now there's technically 2 of those, but we only need it one time. Does this factor cancel with the top? No. That makes this a vertical asymptote. Let's talk about a horizontal asymptote. If we were to multiply this out, it would give us an x squared term on the bottom. So I have 0x squared over 1x squared. So I have y equals 0 is our horizontal asymptote. Let's do our x and y intercepts. X-intercept. So if I plug 0 in for y, that multiplies over to here, and I get 0 equals 3x. Dividing both sides by 3, x equals 0. So I have the origin again. Y-intercept. For the y-intercept, I plug 0 in for x. Plugging 0 in for x, I get y equals 3 times 0, which is 0, over 0 plus 2 squared. So we get 0 over 4, or 0. So again, it's the origin. Here's my graph. Sorry, it's not very straight. So we have a vertical asymptote at -2. Let me put my dashed line here. I have a horizontal asymptote at y equals 0. I also know that this has to cross at the origin right here. So this is one of those special ones because of this double on the bottom. One piece falls over here and approaches the asymptotes. The second piece crosses through the origin but stays close to that asymptote. Number 36. On number 36, they were asking you to look at the graph given and find the vertical asymptotes. You have vertical asymptotes at x equals, and again, remember vertical asymptotes have to be written as x equals because they're vertical lines. We have x equals -3, and also looking at the graph, we have x equals +3. What about a horizontal asymptote? Where is the graph approaching? It approaches the x-axis, which is y equals 0. Looking at number 38, that is also a graph. In this one, there is no vertical asymptotes. And again, looking at that graph, the horizontal asymptote, that graph is approaching both above it and below it, the x-axis, which is y equals 0. All right, let's talk about the word problem. Number 40. Number 40 says you get an 82% on your first test, and it wants to know how many more tests at 100% do you have to get to improve your grade to a 95. So that's plus 100 times we don't know how many tests we're going to do over, now remember when you're finding the average, you take the total number of tests, right? You add up their total and divide by the number of tests. Well, we don't know how many we need, so we still have that x, plus we have the one more that represents 82, equals 95%. So now we're going to go ahead and solve this. I'm going to cross multiply. So I have 82 plus 100x equals 95 times x plus 1. Distributing on the right hand side, we get 95x plus 95. Let's bring this down. Alright, I'm going to go ahead and subtract my x's to the left and my 82 to the right. So I get 5x equals 13. Dividing both sides by 5, I get x equals. Now, if I'm going to take part of a test and I need 100%, I got to take the whole test. So it's going to be x equals 3 test. This type of problem where you're calculating percentages can come up quite often. Let's look at number 42. Number 42 and 44 we have to graph again. In number 42 we have the function y equals 2x plus 3 over x minus 5. Starting with points of discontinuity, because this is factored everywhere already, we have x equals 5. That would make the denominator 0. This factor does not cancel, so that makes it a vertical asymptote. Horizontal asymptote. Looking at your highest degree, which is x to the first power, we get 2 over 1, or y equals 2. Let's find our x-intercept. Plugging 0 in for y, we get 0 equals 2x plus 3 over x minus 5. If we take and multiply this over to 0, it cancels out. So we have 0 equals 2x plus 3. Subtracting 3 over, I have negative 3 equals 2x. So x equals negative 3 halves, or the point negative 3 halves, 0. My y-intercept. We put 0 in for x. So we get y equals 2 times 0 plus 3 over 0 minus 5. We get y equals 3 over negative 5, or the point negative 3/5 and 0. Alright, let's graph what we know. First of all, we have a vertical asymptote at 5. 1, 2, 3, 4, 5. Here's our vertical asymptote. We have a horizontal asymptote at 2. Here's our horizontal asymptote. We have an x-intercept at negative 3 halves 0. So right about here. And we have a y-intercept at negative 3/5 0. Whoops. I wrote those backwards. Let's fix that. Should be the other way around. This should be 0 and negative 3 over 5. Sorry about that. So that falls right about here. So our graph has to go through those 2 points and approach the asymptote. And then we also have a piece up here. To make sure it falls in that upper quadrant, you can test it by plugging in 6 into our function. So we have 2 times 6 plus 3 over 6 minus 5. This is 12 plus 3 is 15 over 1. So at 6, we're going all the way up to 15. I agree, it has to fall in here. Alright, let's talk about number 44, your last one on the assignment. Number 44. On number 44, we have the function y equals 4x squared minus 100 over 2x squared plus x minus 15. So the first thing we have to do is factor everywhere. On the top, I can take out a 4. That leaves me with x squared minus 25, which is the difference of squares. X plus 5 and x minus 5. On the bottom. To factor this, let's first do our x. So negative 30 over 1 is 6 and negative 5. To finish factoring this, We have 6x and a negative 5x. So we take out 2x and a negative 5. We're going to take out an x and a positive 3. Alright, so our factors on the bottom are x plus 3 and 2x minus 5. Alright, so points of discontinuity. We have x equals negative 3 and x equals positive 5 halves. Both of these do not cancel, so they are vertical asymptotes. Let's talk about the horizontal asymptote. Going back to the original, we have x squared over x squared, so we have 4x squared over 2x squared, or y equals 2, and that's the horizontal asymptote. Alright, let's find our x-intercept. X-intercept means I plug 0 in for y, multiply this all over there, and I get 0 equals 4x squared minus 100. So solving for this, I would have 4x squared equals 100. Dividing both sides by 4, x squared equals 25, which means x equals plus and minus 5. Alright, those intercepts would be 5, 0, and negative 5, 0. Alright, our y-intercept. Again, plugging in 0 for x, we get y equals 4 times 0 minus 100 over 2 times 0 squared plus 0 minus 15. So y equals 100 over 15, which reduces to 20 over 3. Alright, so let's graph what we know. Oh, let me move it up just a little bit. Alright, we have a vertical asymptote at negative 3. We have another vertical asymptote at positive 5 halves. We have a horizontal asymptote at 2. We have at 5, 0, 2, 3, 4, 5, we have an x-intercept. At negative 5, 0, we have another x-intercept. So you can see that these approach our asymptotes in either corner. Alright, we have a y-intercept at 23rd. So let's see. 2, 3, 5, 6. Approximately right here. And this also has to approach our asymptotes in either direction. So you'll notice that this has 3 pieces to the graph. I hope this helps explain all the homework we had from Thursday. If you have any additional questions, I'll be happy to answer them tomorrow. And I'll talk to you guys really soon. Go ahead and get the worksheet. Have a great day.